Hello guys, welcome you all for this end-to-end session of AIML. I will say it's a data science. Okay, it's a combination of AIML, DL, NLP, generative AI, everything you guys gonna learn so that you can become a successful data scientist. Hope you guys are enjoying a lot. So we are enjoying, we are learning a lot. Hope the same thing for you guys. So today we're gonna look into a thing called as PCA. Okay, it's one of the like dimensionality reduction technique. Okay, so hope the last session we have discussed is B, DB scan, where we have discussed about the theoretical concept, what is the black box of it, and we have gone through the coding session. Okay, right. So it is one of the super technique, right, guys? So because like it comes under the clustering. Okay. So today we're gonna look into one thing which is called as a PCA. Okay, I will say it's one of a dimensionality reduction technique. It also comes under unsupervised learning. Okay, let us discuss the theoretical concept of this. So guys, before going for the session, as always, make sure you guys are subscribe to our channel so that every day we are posting a new video, right? So that you doesn't miss any of the thing. And before coming to the session, make sure you guys watch all our previous session videos so that you can have a better understanding and a continuation of what we are talking. Okay, so let us discuss about today's session. Introduction to PCA. It's a principal component analysis. So PCA is a powerful dimensionality reduction technique used to simplify complex data by identifying the most important patterns and variations within it. It aims to transform high dimensional data into lower dimensional representation without losing significant information. Okay, let's put it in a simple manner. Okay, that is what we will be doing, right? Without going more complex, PCA is one of the dimensional reduction technique. It comes under unsupervised learning. What it does, okay? Let us consider we have a problem where we need to predict a person has a heart disease or not. Okay, in order to predict a person has a heart disease or not, there are going to be multiple features, right? Blood sugar level, glucose level, gender of the person, what is their food habit, how much cholesterol they are taking, fat they are taking. Like there will be like consider there will be thousands of column. Based on that, we're gonna predict whether a person has a heart disease or not. Okay, consider 1,000 inputs I need to train for each and every records to get a person whether he has a heart disease or not. Okay, how much computation it's gonna take? Okay, whether all the columns that to have a similar precedence or like similar importance to predict the person has a heart disease or not? No, right? What we will be doing means instead of taking all the 1,000 columns, we will be choosing only 10 columns which will represent all other 1,000 columns. That's it. That is called as dimensionality reduction. That is conversion of 1,000 features, that is 1,000 columns, to only 10 columns without losing the information. Because like those 10 columns you are selecting, right, it should have information that can say, that can represent say all of the 1,000 columns. Okay, you should not randomly go and choose. Okay, I'm gonna do PCA, so I'm just reducing these 1,000 columns to only 10 columns. No, not like that. The 10 columns you are converting, right, it is like a, we will call it as a principal component. Those principal component, 10 principal component, should be in a manner that it can explain other 1,000 columns. Okay, that's the reason. And end of the day, there is no information loss, and we will also able to represent the 1,000 columns data in only using only 10 columns. Then it's an advantage for us, right? Instead of passing all the 1,000 inputs, we can pass only 10 inputs to get the person has a heart disease or not. Okay, that's it, guys. Higher dimension data, 1,000 columns to lower dimension, only 10 columns. That's it. That is what PCA. Okay, hope you guys can able to understand. So that is what we are having for PCA. Okay, so let us continue. Okay, so this is what the introduction to principal component. Let's move on to the next thing. Okay, let us understand what is dimensionality reduction before going for this. Dimensionality reduction is a process of transforming data with a larger number of features into a smaller number of features that captures the most relevant information. PCA achieves this by finding a set of orthogonal principal components that represent the direction of maximum variance in the data. Hope you guys can able to understand. Okay, instead of using all the 1,000 features to predict whether the person has a heart disease or not, we can just use only 10 records or 10 columns to predict the same thing. Okay, what there will be anything, okay, because like there will be no change, right? We're gonna have the same 100% information. Why we need to worry about considering all the 1,000 features? No, right? So that is the way. Okay, that is what dimensional detection say. One of the type inside dimensional detection is PCA. Let's see what are the things that it is having, man. Okay, let's see. Okay, simplify data. So PCA reduce the complexity of data by finding the most important feature, making it simpler or easier to analyze and interpret. Yeah, for interpretation, consider I'm gonna use a scatter plot to scatter the data of 1,000 columns. What happened? We are not in a position to interpret each and every columns, right? We will not able to see what data is projected from which column itself. So that's the reason this PCA, that is dimensionality detection, simplifies the data. Okay, next, improve efficiency. PCA reduce computational cost and storage requirement by working with a smaller number of dimensions. True. Instead of storing 1,000 columns, we can now have the 10 columns which represent those 1,000 columns. Computationally, it is less. So because we're gonna train the model on only 10 columns, and storage space of this 10 columns is very less when compared to the 1,000 columns that we need to store. Okay, so it is a improved efficiency. Okay, then let's move on to the next thing, enhance performance. Okay, PCA can enhance the performance of machine learning algorithms by reducing the noise and improving this generalization. Okay, I will say one thing, PCA is not the direct algorithm, it is a kind of pre-processing. Okay, what you will be doing here means I'm gonna throw you a data set with 1,000 columns to predict whether the person has a heart disease or not. You guys gonna get the 1,000 inputs and gonna convert that to only 10 inputs, 10 columns that represent all of the 1,000 columns. Using these 10 columns, you will be projecting, okay, the person has a heart disease or not. Now I'm gonna use this 10 columns with the records, that is the targets. Now I'm gonna apply to any algorithms that I need. I can apply to the classification also, okay, because like now I have reduced the dimension from 1,000 to 10. Now I can apply this 10 inputs to get the output of whether the person has the heart disease or not. So that is what it is, one of the pre-processing technique we will do before going for algorithm. Okay, it's a kind of a pre-processing. Okay, so it enhances the performance. Okay, instead of going for all the 1,000 features and training the model, it is easier, right? When you just able to convert the 1,000 features to only 10 features and do the processing, then it's very easy. Okay, hope you guys can understand. Okay, guys, like if you guys doesn't understand anything, it can be anything, guys. Okay, because like we are here to help you, we are here to teach you, we are here to guide you and mentor you. Okay, that's the reason. Any doubts for you, just ping us in the comment section, we will take up and we will solve your doubts. Okay, let's move on to the next thing. So this is all about understanding dimensional reduction. Now, okay, what is meant by covariance and correlation metrics, guys? I will say any interview will not gonna end without asking this question. Okay, let's see what is covariance and correlation metrics. PCA relies on covariance and correlation metrics to understand the relationship between variables. The covariance metrics measures how variable change together, while the correlation metrics measures the strength and direction of their relationship, linear relationship. Okay, putting in the simple way, covariance tells how the variables are changing, whereas correlation tell how much they are together or strength. Okay, let's see how what is the difference between them. Covariance measures the direction and strength of the linear relationship between two variables. Correlation measures the strength of the relationship between two variables, not direction. When you need a direction, you need to go for a covariance. When you don't need a direction, you can go for a correlation. It affects by scale of the variables. It is not affected by the scale of the variable. So since it looks into the direction, covariance are affected by the scale of the variables, whereas correlation has no relationship or it doesn't consider anything about a direction, so it is not affected by the scale. Okay, hope you guys can able to understand. Okay, so two things, Covariance and correlation, when you gonna include a component of direction together with the strength, go for the covariance. When you doesn't gonna include a direction component to the strength, then you can go for a correlation. That's the only thing. Okay, these two things plays an important role when you guys work on this PCA. Okay, so yeah, that's all about this slide. So covariance and correlation matrix. Let's move on to the next thing. Okay, eigenvalues and eigenvectors, guys. Eigenvectors and eigenvalue. This is also one of the important thing to understand the PCA. How we have understand the covariance and correlation. Now we need to understand eigenvalues and eigenvectors. So eigenvectors and eigenvalues. Eigenvectors represent the direction of maximum variance in the data. Eigenvalues quantify the amount of variance explained by each eigenvector, indicating their importance. PCA selects eigenvectors with the largest eigenvalue as the principal component. That's it. Okay. Let us discuss one by one. Eigenvectors, it has a direction. Eigenvalue, it has a value. High eigenvalues are selected as the eigenvector. That's it. Okay. Vector means there is a direction, right? That's it. So eigenvector represent the direction of maximum variance. Eigenvalue quantify the variable or a variance explained by the eigenvector, each eigenvectors. Principal component, eigenvectors with the largest eigenvalue. Hope you guys can able to understand the relationship between these three. Okay. Eigenvector means it will represent the direction of the dataset. Eigenvalue means it will explain, it is a value which explains the eigenvector. Okay, it is a value which explains the eigenvector. Principal component means eigenvectors with larger eigenvalue or largest eigenvalue is called as principal component. Okay. Hope you guys are able to understand. So yeah, guys. So this is what we have introduced you. What is PCA? Okay. Let us summarize. So we will pass here. We will summarize the things what we have learned today. So we have introduced you what is PCA, what is dimensionality reduction, how a PCA works, why we need PCA, what is a kind that we need to look into PCA. We should not look into a PCA in a kind of an algorithm. It is a pre-processing technique. So what are the important components that are present in PCA? Finally, we have end up with the eigenvectors and eigenvalue. Okay. So hope you guys have enjoyed today's session. So today's session is a simple session where we have introduced you PCA, a type of dimensionality reduction technique which is under the unsupervised learning. Okay. So hope you guys have enjoyed. So like if you guys have any doubts related to this, please let me know. Okay. Because like you guys need to understand this end to end so that you can build anything on top of it. Because like we're gonna have lots of project, lots of hands-on session we're gonna conduct, and as sir was mentioning before, we're gonna distribute a prize for top 3 performance. So make sure like you guys are just able to complete all the assignments that we are giving. Okay. And whenever we are just explaining you the coding session, right, guys, make sure you guys just continue to work hands on whenever we are just doing it. Okay. Parallelly you guys also do, so that I will say one thing from my experience. I'm just saying, so whenever you are just listening to whoever teaching you, you are able to understand only 50 to 60% of it. You are able to, when you are able to digest it and write it down, then only you can able to understand it 100%. Okay. I need you guys to understand each and every concept that we are teaching. So if you guys stuck anywhere, just come here, go to the comment section, ping us in the comment section. We will take up your doubt and we will solve your doubts. Okay. So yeah, guys, this is all about this session. So we have introduced you PCA, the theory part, and black box. Let us continue this PCA theory part in the next session. And yeah, guys, this is all about today's session. And guys, please make sure that you guys subscribe to our channel, because like every day we're gonna upload a new video, so that when you subscribe to our channel and press the bell icon, so that you will be getting the notification whenever a new video is uploaded onto, so that you guys doesn't miss any of the things. And one more thing, guys, if you guys need us to give some improvements tips, okay, like constructive tips that you guys need to give us, we will take up and we will try to change the things, because like every day we are learning, guys. This is new for us, but we are here to give something we have. Okay. We need some revolution from you guys. Okay, that's the reason. So learn well, guys. Happy, keep learning, happy learning. So we will all meet in the next session, guys. Until next session, bye guys, take care. We will all meet in the next session. Bye guys.